video about grid connected wind farm with STATCOM and DFIG model. So in this Simulink, we are going to check that performance of the power system with STATCOM and DFIG integration. So here the purpose of that STATCOM and DFIG, here we are connected to check and control that reactive power compensation. So the system with general analysis, modeling and control of that DFIG for large wind farm application. So here in the DFIG model we use the detailed DFIG analysis along with that system controlling. So here we can check that control part. So here we done that wind turbine, the torque is controlled that DFIG model, and we done that MPPT technique for reference torque, and we done that back-to-back converter controlling here, and here we can check that result for DFIG system. So this is belongs to the turbine, and this is belongs to rotor side control, and this is belongs to grid side control. So and the common coupling is interfaced with that power system grid. And this is the 48 pulse STATCOM with 3-phase transformer we done, and as it is the DFIG, we connected the STATCOM also the common point of the power system. And this is the 48 pulse generation for STATCOM controlling. And this is the 3-phase grid. So for DFIG we done that vector controlling strategy, and for STATCOM we done 48 pulse generation for STATCOM controlling. So the implementation of STATCOM as a reactive power compensation at point of common coupling to support that DFIG based wind formed during the disturbance. So the integration of the fact device product that grid connected DFIG based on wind farm when going to offline during that offline during and after the disturbance. So this is way to we check that device transient performance, and along with that fault detection. So here we can check the performance of that each bus. So it should be the result should be the transient one.